Okay, so I this one is really tough for me because of the implications, for national security. Um, because it has to do with the communications factor. But because it is so integral to my book and to the entire concept that I've been working on about the resources and the possibilities that are out there for us to be able to actually do these things, and whether or not God created the universe for us to go out there and do it, right? So the communications were so important to me because of the radio delay of only being able to communicate at light speed. Like, for example, we go to Alpha Centauri, we have a 10-year delay between the communication and the response time. So you ask me a question and I get it in 10 years, and then you get the answer back 10 years after that. Now, it's not going to be a feasible thing to use radio, except for at very short ranges when we're talking about spatial distances. But there's something that was discovered during quantum physics, which actually I looked it up, and it was actually discovered before radio. And it's called quantum entanglement. Now, this is where they take two atoms and somehow miraculously entangle them together in such a way that when they're separated and the spin of one is changed, the spin of the other is automatically changed, no matter how far apart they go, no matter what's between them, and all these other things. Or whatever. So, even if these two atoms are on different sides of the universe, or in two different galaxies, they will instantly change. If one spin changes, the other one's spin changes. So that's a 1 and that's a 0. The spin change. It's regular spin and it's change spin, okay? You got a 1 and a 0. That's the foundation of communications. And it's instantaneous. This means that now Alpha Centauri, we can communicate with it, with our cruiser, headed to Alpha Centauri instantaneously, providing, instant updates, the ability to learn what's happening to it, right now, so we can help it. And it's not just for other star systems. It's also, the 7-minute delay between here and the sun, radio delay from here to the moon, or out to Ganymede, Enceladus, Neptune, all of these things. Now, the reason that I was so concerned about it for national security is because there's no waves that can be intercepted between the two. So the communications can never be intercepted. It's only from this atom to this specific atom, so it's not a broadcast. It's a two-way communication. And then also, the primary concern for national security is once all the other nations begin to have their own nations and their own resources that they build in space too, and we have fleets, that radio delay, if they don't use Keycomm, Q-E-COM, right? If they don't use Keycomm, then that radio delay against a nation that does have Keycomm is totally asymmetric. And so it was kind of important to me to keep it a secret, but it's like readily accessible nowadays on the internet, and they call it different things. DARPA's calling it teleportation and these other things, you know. And supposedly China developed a radar system using the technology, and I couldn't imagine how that would work, because they were saying that it could detect stealth aircraft. And so I was thinking that they must have a certain length, because you have to contain the atoms within an electromagnetic field in an accelerator. And so they must have a certain length of an accelerator where they're monitoring. I mean, first of all, they're going to be producing at one end the entangled atoms, and they're reading one, and then out the other end is shooting the other one. And so they're reading the spin, and it must be hitting, when it hits a stealth vehicle, it must change the spin somehow. So stealth has obviously electromagnetic planes to help it to deflect radio from radar. But because it only has, because they can't measure it infinitely, it's not a self-contained accelerator. It must only be a tube, because that other atom is flying forever, and it's got a steady stream, right? So they have to monitor every stream, not just the one photon. Okay? So because of that, they must be monitoring the stream of photons, and therefore that Keycomm radar must only have a limited distance. But anyway, and there was something else too that had to do with a different topic.